This is the nut for the Hardtail Vise. This is the one that was supplied with it. And it's just a casting, even though they got a little bit of turned area down here on the ends, the flange, but they didn't turn any of this. Now the print spec'd out for the through hole, the bore for this to slide through being at 2 inches. And this measures about 100 thousandths over that, depending on where you measure it. I'll get anywhere from about 85 to 100 thousandths oversized. So my intentions was just to turn this down to 2 inch to fit that bore, and then we'll have a nominal size bore through the tail housing right there. And again, I plan on machining one of these myself. We're going to do that later on, and it'll be nice being able to turn this down to a nice nominal size. So let's see if we can get this turned down. It's definitely not running true. This is just a casting, remember. We get our feed rate set. A little tricky to get a good diameter when it's running out this far, and I don't care if it doesn't clean it up round. We really just want to get it to it fit the hole. I am running a coarse feed, 14 thousandths per revolution. Let's see what kind of measurement we can get right there. 2" 56. So let's go ahead and we'll make one pass down this to kind of get most of it off, and then we'll make a finish pass. Right there, it cleaned it up. Setting the 0 right there. The 0 on our cross slide. I'm going to give this thing 5 thousandths clearance to slide down through that hole. Nothing really critical there. We just want it clearance to fit through. All right, so we got about 35, about 40 thousandths still to come down. Let's see how straight it is. So I had about 2 thousandths taper in that cut right there. Not a big deal at all. Okay, we'll compensate. We'll go ahead and make one finish pass, get that finished up. Go ahead and give this a check with the mic, see if we landed on our target. Looking for 5 thousandths clearance. And we have it, and we landed on a nice straight size. Usually the finished cuts will cut nice and straight. When you're roughing in and taking heavier cuts, you're prone to get a little bit of taper like that with everything kind of moving the way it is. So that looks good. Got a good finish on it. We do need to just machine a chamfer on that end to clean that up, and that part will be finished. All right, let's give it a fit check right here too. Flange in, fits. And looks like the bolt holes are lining up. That's going to be good. Obviously we can't go all the way down because it's longer than the tail housing there, but that 5,000 seems like that's a nice fit to be able to install it. So moving on to the second setup for our hardtail casting, I need to make sure that the alignment of this side right here, our hole pattern and everything, actually the hole pattern is the main thing that we need to make sure is on center. So since we have this guy centered here on this end, I would like to try to maintain that center line going all the way up through to the top side whenever we machine this side right here. So my idea on tackling that is I'm going to make a simple little fixture, like a little plug that's going to bolt down to the mill table. I've got this piece of 1045 chrome rod stock that I can use to make this. We'll just machine it to fit this nice and close. It'll be bolted down to the table, and then I can go ahead and probe this and find our work location X and Y here, and our Z location for our work offset is going to be off this face here. So the machine table will Z off of that, XY center on this bore. And then once we do that, then I can basically just set that down on that alignment plug, and that should be in the center. And I'll just have to indicate it side to side that way, because I am going to have to move our angle plate out of the way so that I can get down here all the way to the bottom and be able to find the center of that little plug. But I think what we can do is just set the thing down on there and kind of bump this nice and straight on these sides right here. Just get that in line. Maybe hold it down with a couple clamps, and then slide our angle plate back up to it, and then pull it up that way. And once we get it clamped in, this should be aligned, and then we can remove those two toe clamps out of the way that's holding it temporarily. That's my idea anyway, so let's give it a shot and see if we can make that happen. This is the bolt that I want to use to hold the plug down. I need to counterbore it only so that I can get the proper depth that I need to reach it with the threads, because I either have this bolt, which is a little too short, or I have other bolts that are too long. So I'm going to counterbore it just so that we can make this one work here. Just using a counterbore tool here. And that was the wrong oil. I want cutting oil for this one. Don't need to go far, about a 1/4 inch, 3/8 deep. Something about like that. So once that's flush, that should give me enough thread to hold that in there. That'll be good. All right, so there's our alignment plug there. By the way, we got our counterbore, so now you can see what I mean. We got just enough threads there to keep it held down to the fixture plate good. Give it 2/1000 clearance, and it won't bottom out on that interface there. We'll be able to pull it right down to this face here as well. All right, so I'm going to go get this guy set up in the machine. Another thing that I want to do is actually go to the granite plate, set it down on that face there, and I want to get a measurement using a height gauge and find out what the lowest point is, because as the program is written right now, it's showing that we're going to take 300 thousandths off this face right there. But what I'd like to do is minimize the amount of cuts that we have to take and measure what the lowest point is and see if we can add a little bit of our height there. A little bit of height on that is really not going to matter. Dimensional wise on the print, it says 15 inches. So right now we're 15 inches, 300 thousandths. So if I can add another 1/8 inch to that, that'll save a little bit of material that we're having to face off of this. Okay, there's our little alignment fixture that we machined. I actually had to counterbore a little deeper. I forgot that these tapped holes in the fixture plate are actually counterbored themselves, so I lost about a 1/4 inch of thread there. So I had to take that down another 1/4 inch, just enough to hold it in place. So we'll go ahead and use our probe to find the center of this, and this is going to be our X, Y, 0, and then our tabletop surface is going to be our Z0 right there. So once we do this, we'll be able to get it kind of pulled down, get it aligned nice and straight with the X axis there, and then we'll be able to put our angle plate back on there and just pull it up to wherever this is clamped down to. I wanted to show you guys this measurement that I was referring to earlier about getting our height. So we're on the granite plate, obviously. I'm using one of my taller height gauges. I've already done a measurement on this, but all I was doing was I started off in the center, since you have a crown in the middle, and I touched off the height gauge at the highest spot, and that was in fact 15 inches 300 thousandths is where it should have been. So 15 inches 300 to the top. And what I did was I just started going around all 4 sides of it, looking for the lowest spot that I could possibly measure there, which is going to be right in there. You can see the tip of the height gauge is just coming over onto the cast. And then if you come down here to this area, so this side right here is actually the lowest, right against that corner. All right, and then so this actually measures 15 inches, 150 thousandths. So it's probably off a couple thou, because I'm just trying to round off to the nearest. This right here is why I really appreciate my digital height gauge, because it's just instant reading, where these guys, you really got to get in there. It's even better if you got a magnifying glass you can put in front of it to make reading that vernier scale a little bit easier. But the point I was trying to make is that to the highest point Should have said the lowest point actually is 15 inches, 150. This side over here, if we bring the height gauge around here, this side is higher, so it's touching that corner, the edge. So we know this side is going to be a little bit higher right there, which is good. This is when we start our cut, it's actually going to be this side right here. So what I did is I modified our program for the facing op. What I did, I measured, I changed the dimensions of our stock from finishing it at 15 inches. I'm actually going to finish it at 15.125. Since this is measuring 15.150, we know that once we clean this all up right there, it's going to take about another 25 thousandths off this face to be completely clean, eliminating an extra 125 thousandths that we don't really need to take off of it. That length right there is not super critical, so it being an 1/8 inch longer than the print says, it's not going to make or break the build of this. So just wanted to share that with you. It was a really easy, convenient way of getting this exact measurement since we had the machine face on the bottom side there. So we'll go ahead and start getting it set up on the mill now. It looks good right there. We had that one pretty close. All right, so we just need to tighten down our angle plate right there, tighten this guy up. I'm going to put our toe clamps back on the angle and we'll be ready to roll. Whenever we were setting our tools up and we started on the opposite side there, I'd mentioned that I was going to go ahead and get started running our high-speed steel drill bits, and I had the solid carbide drills on order. So they finally arrived. This is the new Walter solid carbide drill. This is a 21/64 drill bit, which is going to be a clearance hole for 5/16 diameter bolts. So I'm just going to use tool 23 since we're through with that. I'll take this guy out. We'll put a 3/8 collet in there. We should be able to use this guy right here, I believe. Maybe it's the next one up. I need to check that. But we'll go ahead and use tool 23, swap this out, and run our solid carbide drill for this second operation. Here's a 7/16 collet. Maybe that'll be the one that we can use. I just got to get it in there and see which one it'll hold. I thought it was going to be 3/8. I don't remember now. I believe we got this thing ready to machine. Go over another little detail over our setup there. I actually did some inspecting on the bottom using the thickness gauge, feeler gauge there, and I ended up shimming the back side of it here because I figured out that it wasn't pulling it up square to this face right there since this is simply cast. So it was kind of pulling it in just a slight amount of a bind. And I've got it about as close as I can because I've been screwing with this thing for probably about an hour trying to get it set up. I've got a 2/1000 feeler gauge here and it just barely wants to go in that side right there. And it feels that way around that front side right there. So that's about as close as I can get it with the feeler gauge. So I feel like it's pretty well square. It's not absolutely perfect, but I don't think that it really matters at this point. I think I've got it really close enough. So that is tight. I believe that's ready to go. I've been testing it, cutting air up here and making sure our tools are where they need to be. I will say that it's going to be cutting a little bit more off of this side. Like this side's going to be completely cleaned up. I believe this side right here, which is the top, it's not actually going to clean up this side right there. It's going to cut about half of it and leave this in. But I have checked it, I've rechecked it, I've rechecked it again. I've gone back to my prints, I've gone to our modeling, and it's where it needs to be. So I'm not really sure why it's offset more, other than it just being a casting, and that's just the way it's going to be. So just wanted to point that out. Side to side, these right here, it's really hard to tell if both of them are going to clean up. There was really very little material that needed to come off of this side right there. It really doesn't need to be milled, but I was going off of the print specifications. So if it does cut, it may be about 10 thousandths on that side. All right, so we'll start with our face mill, face it off. I adjusted it so that we're 15 1/8 of our finish pass there. We'll drill it with a 21/64, and then we're going to do a chamfer, and then that'll be it. So I'm ready to see this guy finished up. Let's go ahead and start machining. This first pass, I don't think it's going to cut very much, maybe just a little bit in the middle, kind of the same as the other side. Okay, well that completes our facing operation. We got her done and it looks good. I know that this isn't the way that a lot of you guys would machine this, but this is the way that I chose to machine it. And I'm continuing to learn. So as I continue to work on these projects, I'm gonna be able to remember and be more aware of tool paths that I can make that's gonna actually speed up these operations and optimize them. But we're doing one part right there and I'm not in a hurry, and I enjoyed watching it do its thing. So I'm gonna swap out that tool. We're gonna go with our 3/4 end mill, and then now we're gonna go ahead and get the frame of it milled. Tool 21 is installed. Tool reset. Cycle starts. There we go. Now we just got to load our program and we'll be ready to mill. Just going to walk this down and make sure that it's clear in the bottom of the part before we begin. It looks like it is, so here we go. That's it. Minute 40 seconds for that one there. And as I suspected, it didn't really clean up this side, so it was cutting a little heavier. It looks like it actually cleaned up the other side and just barely touched that. So I'm thinking that's just the cast, just the way that it was cast. Everything ain't perfectly on center. The one that I have on the bench is not even machined on those sides. It's still the rough cast siding. So anyway, let's go. We'll swap that tool out. Next operation is going to be our 4 holes. Okay, here we go with our drilling cycle. "16 seconds, that's all it took. Okay, this will be our last stop. This is our chamfer. I'm going to come up on this slowly and make sure that it's cutting properly. Yep. Got a 15 thou chamfer on this, just to break the sharp edge off. All right, that looked good. Well, that's gonna complete all the machining for the hardtail casting there. I think it looks good. Finishes look good. I need to get in here and I'll just take a file and deburr that inside. That's inside sharp edge, get rid of those burrs. The outside, chamfer cleaned it all the way up, all the way around. So we are good to go. I'm gonna go ahead and start the disassemble of our fixture here and get it out of the machine. Using a hardtail vise to work on a hardtail vise. I'm starting the assembly of our parts that we just finished here, the tail housing. I want to get it bolted on there, see how it's going to fit up, put our nut inside the tail housing and make sure it's going to fit. So I just went down to National Standard Parts, got some bolts. These are going to be the bolts that I'm going to use to mount it to the table there, just like we did on this guy. I like the stainless. So I opted for stainless steel because I think they just look nice. So you can see there's the stainless for the top. So this is something right here that I thought I would share with you guys. This is a mistake that I made earlier on that I caught and I didn't mention it in video because I just wanted to continue on with the project. So you can see that this bolt right here, I knew that it was going to be really close to that sidewall right there. I just went ahead and went with it, and I've been turning the head of this bolt down to see if I get it to fit, and it's still not going in there. I got to do a little massaging to this area of the cast. So I'm going to probably do a little bit of milling just off camera, just take that down just a little bit so that I can get these bolts down in there. Okay. The problem is that on the print, when I was looking at the prints, this bolt pattern and this bolt pattern is on two different prints. But I was looking at the bolt spacing for this bolt pattern right here on the print that I was using when I was machining this guy. These are 2.5 center to center, and I drilled and tapped these guys 2.5 center to center, when in fact these were supposed to be 3.5 center to center. That was on a different print, and I didn't study it hard enough to realize that those were not in line right there. So these actually should have been further out here, which would have put them more towards the corner of the flange there, and they probably would have fit in there. And I'll show you what I'm talking about right here. You can see it's right there on the corner so that it gave it more clearance to be able to get that bolt in there. Regardless, it's still a pretty tight fit in there. And the other thing too was that they used 1/4 inch bolts where I used 5/16 for everything. So it's a little bit bigger diameter. So kind of backing myself up against the wall right there, if you will, but you can see that it's really, really close. I'm just gonna set this up and just do a little bit of milling right there, just enough till I can get that bolt in there. So anyway, I wanted to point that out. Another bonehead mistake that I made, but I don't think it's gonna matter. Once you put this thing together, nobody's gonna know, right? So I'm gonna continue getting this thing assembled. I wanna see what this looks like with our tail housing and nut bolted to the main vise body there. Well, we got a partial assembly on the thing. I know that it's gonna go together, but I still got a little bit of work to do to get all the components to fit. But it's looking good, and I'm happy to finally see this coming together the way it is. I love that rotational movement on it with our more precision fit on our swivel bolt and the swivel base there. It's got a nice feel to it as you swing it around. It's not, you know, sliding back and forth in the middle there. So another thing that I've got to work on here, this nut right here, the holes were not drilled directly in the center there, so I can't get the second bolt to actually start on the threads. So I'm going to have to set this nut up and just, these were drilled exactly 5/16, and I wanted to use 5/16 hardware. The factory uses 1/4 inch hardware, so I wanted to step up one size. So I'm actually going to have to drill that hole or slot it a little bit, just a little bit, to get this other bolt to go in there, but that's not a big deal. I was also going to take these guys and turn the heads of the bolts down just a little bit to match the counterbore that's already drilled into this nut right there. But I still plan on building my own nut later on. We're going to build a nut and a spindle for it, and so once we do, you know, I'll have everything kind of machined to match to my own specifications, my own standards there. Can't get the bottom bolts in. We already mentioned that. Going to have to do a little massaging on the casting there since it's such a tight tolerance. So going to be working on that. And then a couple other things that I wanted to point out that I want to do is the feet here for the swivel base. I want to set these guys up in the manual mill and run a face mill across this right there to clean that casting up on all 4 of those ears and make those look a little bit more uniform and nice, have a nice machine flat surface. I'm going to use these stainless steel bolts to hold it down, but I am going to machine my own stainless steel washers to go on here. They'll be machined to a much closer tolerance, have a nice looking finish on it, and we'll machine it to have like a nice diameter to match right here. I'm also going to do that with these guys right here, where these clamp bolts that you tighten down. Let me go ahead and just take one out so you guys can see what I'm talking about. There's a couple things I'm going to do with these guys here as well. Okay, so this is the factory supplied clamp bolt right there. Nothing wrong with this. I'm going to use this. You can see I already put one of my heavy duty 5/8 washers on there. This area here, this ear, I actually want to machine that as well. Whenever I get it set up in the, maybe in the shaper, I'm not sure. I might go ahead and just skin this, have a nice machine surface there. And then we'll also machine some nice stainless steel washers to match this body diameter right here. So that'll all look good. I like the stainless steel contrast that it brings whenever you have carbon steel against stainless steel or even a painted surface. I just like the look. So I think that's going to look good with some nice custom stainless washers right here and those machine finishes there as well. So making really good progress on it. We're getting much closer, and we're kind of down to the final machining steps that we got to take, which is going to be machining the inside of the main body right here. I'm going to get this guy, take the tail housing back off. We're going to go ahead and move this guy down to the home shop where the shaper is, and we're going to set up, and we're going to have to machine this surface right here, and then also on the inside, so that this inside rectangular shape will be close tolerance and fit our dynamic jaw body right there. That's the goal. Probably going to go ahead and take this guy home as well and get this area machined right there. We'll just probably use the shaper and get that done. So that'd be something else I'm going to start working on. Here's a little update on the tail housing for the Hardtail Vise. I came in here with a couple of end mills. I used this 1/2-inch tongue force rec, tongue alloy insert mill, finished it out with 3/8 diameter solid carbide. All I did was just kind of mill a couple of pockets out. I ended up taking from touch off, I went down 40 thousandths, and that was enough to allow the head of these bolts, without turning the head of the bolts down, to be able to go down in there. And I went ahead and cleaned up the face there as well, so that the head of the bolt would be pulling down on a nice square machine face. Did that on both sides. So I think that's going to work out pretty good. It's all we need to do to get those bolts to fit in there like they should. I clamped it in there. We used some brass shims, and I bumped everything around. I got this indicated, I got this indicated, so it's nice and square with our machine face there on the back side. So not a lot of work involved in that. I probably did that in a matter of 15 minutes, had this all set up and ready to go. And I just wanted to show you this little update. So now I can get this tail housing bolted up to the main body without worrying about jamming in those bolts there. Okay, we got the tail housing bolted on there now, and our little clearance modification on the bottom side worked out good. So I was able to easily screw in both of those cap head bolts, and that's going to be just fine right where it sits. So that is done. Another thing that I did earlier before this is I had to modify the bolt holes at the end of the nut right here. So the factory uses 1/4 inch hardware. These were drilled 5/16, so I actually drilled and tapped the end of it for 5/16. So that ended up making the countersink a little bit too big. I did this kind of knowing that I was going to be, again, backing myself into a wall here, but all I had to do, I got me some 5/16 flathead bolts, stainless steel, and I turned them down. I went ahead and set this up in the mill and lined up both of those holes and went ahead and run the chamfer in there like you see, cleaned it up, made it just a little bit deeper, turned these heads to match, and they both fit in there beautifully now. It looks really good. I'll get that bolted in to the back of the tail housing here and show you what that looks like. All right, there we have it. There's the nut bolted in. I like the way that those larger 5/16 flathead bolts looks on there, even with the modified head diameter. I think that's going to wrap up this video, guys, of getting our tail housing machine. I can see the finish line in sight, so we're getting really close, but I've been having a lot of fun with this project, and I hope that you guys have been enjoying it too, and continue to want to follow along and watch us use our old school machines, our new machines, and all the measuring techniques that we got to get this guy machine and get it put together. I've been enjoying sharing it with you, and I hope you guys have been enjoying it too. So that's it for today. I hope to see you guys on the next video.